Equation of a tangent 1. Equation of a tangent to a circle at a given point. Here's our circle, here's our tangent, and this is the point. A tangent is perpendicular to the radius that joins the centre of a circle to the point of tangency. This is the centre, this is the radius, this is the point of tangency, and the radius meets the tangent at a right angle. This fact is used to find the slope of the tangent. In the diagram on the right, the radius r is perpendicular to the tangent t at the point of tangency P. The equation of a tangent to a circle at a given point is found with the following steps. Number 1. Find the slope of the radius to the point of tangency. 2. Turn the slope upside down and change its sign. This gives the slope of the tangent. 3. Use the coordinates of the point of contact and the slope of the tangent at this point in the formula y minus y1 equals m times x minus x1. This gives the equation of the tangent. Remember, a tangent is a line. Note, a diagram is often very useful, so draw out a diagram for yourself, just a rough one. If the slope is a fraction, use the alternative formula bracket y minus y1 bracket equals m times x minus x1. You don't need to do this, you can just stick with this formula, it's fine. It's just that if you have a fraction in place of m, let's say you had 3/4, well, in order to get rid of the fraction, you could multiply across by 4, so you'd end up multiplying each of these two terms by 4 as well. Or you could just stick a 4 in front of a set of brackets. That's why they're saying that you could use this formula either. But you can just stick with this one. This is the one that's given in the formula book. Find the equation of the tangent to the circle x squared plus y squared minus 4x plus 6y minus 12 equals 0 at the point 5 minus 7 on the circle. So our equation is x squared plus y squared minus 4x plus 6x plus 6y minus 12 equals 0. So if we want to get the centre, we take the coefficient of x, which is minus 4. We divide it by 2 and change the sign to get 2. We take the coefficient of y, which is 6. We divide it by 2 and change the sign to get minus 3. So the centre is 2 minus 3. Then we want to get the slope of the radius, so we use the centre point. We label it x1, y1, and we use the point given in the question. We label it x2, y2. We substitute into the slope formula, and we get minus 4 over 3. So this is the slope of the radius, the slope of r. Therefore, the slope of t, the tangent, is 3 over 4. We turn it upside down and we change the sign for the perpendicular slope. So 3 over 4 is the slope of the tangent. So the equation of t, the tangent, is y minus y1 equals m times x minus x1. So we're using the point 5 minus 7 for x1, y1. So we have y plus 7 equals 3 over 4 times x minus 5. So we swap the m for 3 over 4. That's the slope of the tangent. Then multiplying out and simplifying and everything on the left, we get 3x minus y minus 43 is equal to 0. So here's our circle. Here's our centre, 2 minus 3. Here's our radius. This is the tangent. This is the equation that we were trying to find. This is the point of tangency, 5 minus 7. So the equation of this tangent is 3x minus y minus 43 equals 0. Proving that a line is a tangent to a circle. A line is a tangent to a circle if the perpendicular distance from the centre of the circle to the line is equal to the radius. Prove that the line 2x minus 3y minus 27 equals 0 is a tangent to the circle x squared plus y squared minus 8x plus 4y plus 7 is equal to 0. As we do not need the point of contact, we use the perpendicular distance method. So if we needed a point of contact, we would have to solve simultaneously, but we don't need a point of contact. So this is a much shorter method. So we take our equation x squared plus y squared minus 8x plus 4y plus 7 is equal to 0. We take the coefficient of x minus 8, we divide it by 2 and change the sign to get 4. And we take the coefficient of y, which is 4, we divide it by 2 and change the sign to get minus 2. So the centre is 4 minus 2. The formula for the radius is the square root of g squared plus f squared minus c. So the g is 4, the f is minus 2, and the c is 7. Into the formula, and we get the square root of 13. So this is the length of the radius. So the perpendicular distance from the centre 4 minus 2 to the line 2x minus 3y minus 27 equals 0 is given by our perpendicular distance formula. So we label our line A, B, C, and we label our point x1, y1, and we substitute into the formula. So this formula is given in the formula book. Subbing into the formula and simplifying, we get the square root of 13. So the perpendicular distance is the square root of 13. The radius is also the square root of 13. So as the perpendicular distance from the centre of the circle to the line is equal to the radius, the line is a tangent to the circle. So the perpendicular distance from the centre to the line is the square root of 13, and the radius of the circle is also the square root of 13. So therefore, this line must be a tangent. Length of a tangent to a circle from a point outside the circle. The length of a tangent from a point outside a circle is the distance, d, from the point outside the circle to the point of tangency. So we start by finding the centre C, so the centre point of our circle, and the radius length r, the radius length of the circle. Then we find the distance L between the centre and the point outside the circle. So this is the centre, this is the point outside the circle. We find the distance L, and we use Pythagoras' theorem to find d, because this is a right angled triangle. So c squared equals a squared plus b squared, or you could say L squared equals r squared plus d squared. A tangent from the point 3, 0 touches the circle x squared plus y squared plus 2x minus 4y plus 1 equals 0 at Q. Find the distance of PQ. So here's our equation, x squared plus y squared plus 2x minus 4y plus 1 is equal to 0. We get the centre by dividing by 2 and changing the signs of the coefficient of x and the coefficient of y. So we get minus 1, 2, so this is the centre. We get the radius using this formula, and we substitute into the formula, and we end up getting 2, so the radius is 2. So the distance from the centre, minus 1, 2, to the point 3, 0, is going to be given using the distance formula. So we substitute into the distance formula and we simplify to get the square root of 20. So let's have a look at our diagram. So here's our circle. Here's our centre point, minus 1, 2. Here's our exterior point, 3, 0. We got the radius to be 2. We got the distance between the centre and the exterior point to be the square root of 20. Now using Pythagoras' theorem, we will find the distance between P and Q. So we can use c squared equals a squared plus b squared. So we can label our triangle CAB, so A is what we're looking for. So c squared equals a squared plus b squared. Or you could say PQ squared plus QC squared equals PC squared, whichever you want. And subbing into Pythagoras' theorem and solving, we get the length of PQ to be 4. So the distance between P and Q is 4. Equation of a tangent 2. Tangents parallel or perpendicular to a given line. We make use of the fact that the perpendicular distance from the centre of a circle to the tangent is equal to the radius. Note ax plus by plus k equals 0 is a line parallel to the line ax plus by plus c equals 0. So we have ax plus by, and then it's just the constant at the end is different. We have k and c. So these two lines are parallel. And bx minus ay plus k equals 0 is a line perpendicular to the line ax plus by plus c is equal to 0. So notice that the coefficient of x swaps with the coefficient of y, and the coefficient of y swaps with the coefficient of x, and then the sign between them changes. And instead of plus k, we just have plus c, or vice versa. Find the equations of the tangents to the circle x squared plus y squared minus 6x minus 2y minus 15 equals 0 that are parallel to the line 3x plus 4y plus 20 equals 0. So we start with our equation x squared plus y squared minus 6x minus 2y minus 15 equals 0. We get the centre by dividing by 2 and changing the signs of the coefficient of x and y. So we get 3 and 1, so that's our centre. We use this formula to get the radius. So we substitute into the formula and we get 5 for the radius. Let the equations of the tangents parallel to 3x plus 4y plus 20 equals 0 both be represented by 3x plus 4y plus k equals 0. So the 3x and the 4y don't change because the lines are parallel. All that changes is the plus 20 becomes plus k. As 3x plus 4y plus k equals 0 is a tangent to the circle, the perpendicular distance from the centre of the circle 3, 1 to this line is equal to the radius of 5. So here we have our diagram. Here's our circle. Here's our centre, 3, 1. Here's our line, 3x plus 4y plus k is equal to 0. This is our tangent. And our other parallel tangent is 3x plus 4y plus k is equal to 0. So we don't know what these k's are. And we know that the distance from the centre to the line gives us the radius, which is 5 units. So this must also be 5 units. So we use our perpendicular distance formula. So we label our line as A, B and C. And we label our point as x1, y1. So this is our centre point. We substitute into our formula. Remember that we have a k in our formula. So that's from our equation of the tangent. And we let it equal to 5 because we know that the radius is 5. Then we simplify. 3 times 3 is 9. 4 times 1 is 4. Bring down the plus k. 3 squared is 9 and 4 squared is 16. So we have the modulus of 9 plus 4 plus k all over the square root of 9 plus 16, and that's equal to 5. We simplify. 9 plus 4 is 13. So we have the modulus of 13 plus k. And 9 plus 16 is 25, and the square root of 25 is 5. And again, that's still equal to 5. And then multiplying both sides by 5 to get rid of the denominator 5 here, we get modulus of 13 plus k is equal to 5 times 5, which is 25. So we end up with 13 plus k is equal to positive 25, or 13 plus k is equal to minus 25, because the modulus breaks it up into two sums, one where we have plus 25, one where we have minus 25. So then solving for k, we get 12, and solving for k on the right, we get minus 38. So then all we have to do is substitute the 12 and the minus 38 back into our equation of our line, which is our tangent. So thus the tangents are 3x plus 4y plus 12 is equal to 0, and 3x plus 4y minus 38 is equal to 0. Equations of tangents from a point outside a circle. From a point outside a circle, two tangents can be drawn to touch the circle. So here we see our circle, our centre. We have a tangent and another tangent. And remember that they meet the radius at right angles and they have a common point. Method for finding the two equations of the tangents from a point x1, y1 outside a circle. Step 1. Find the centre and the radius length of the circle. A rough diagram can help. Step 2. Let the equation be y minus y1 equals m times x minus x1 and write the equation in the form of ax plus by plus c is equal to 0. Step 3. Let the perpendicular distance from the centre of the circle to the tangent equal the radius. Step 4. Solve this equation to find two values of m. Step 5. Using these two values of m and the point x1, y1, write down the equations of the two tangents. Find the equations of the two tangents from the point 5 minus 3 to the circle x squared plus y squared minus 4x plus 8y plus 12 is equal to 0. So we start off with the equation x squared plus y squared minus 4x plus 8y plus 12 is equal to 0. We want to find the centre, so we divide by 2 and change the sign of the coefficient of x and the coefficient of y to get 2 and minus 4. So the centre is 2 minus 4. Then we use this formula for the radius. So we substitute into the formula and we get the square root of 8. So if we have a look at our diagram, here's our circle. Here's our centre, 2 minus 4. The radius is root 8 and root 8. And here's the exterior point 5 minus 3. Here's our tangent and our other tangent. We have a point 5 minus 3 and we need to find the slopes of the two tangents. So we use our equation of a straight line formula. So the equation is y minus y1 is equal to m times x minus x1. So we label our point x1, y1, and we don't have anything for the slope because that's what we're trying to find. So we multiply out our brackets. So we end up with y plus 3 equals mx minus 5m. And then we rearrange to get the x term first, then the y term, and anything that's left over is the constant. So we have mx minus y plus minus 5m minus 3 is equal to 0. So this is in the form of ax plus by plus c is equal to 0. So m is the a, minus 1 will be the b, and minus 5m minus 3 will be the c. So the perpendicular distance from the centre of the circle 2 minus 4 to each tangent is equal to the radius, the square root of 8. So the perpendicular distance from the centre to the tangents is equal to the square root of 8. So we have our equation of the straight line. mx minus 1y plus minus 5m minus 3 is equal to 0. So we take our formula for the perpendicular distance, we substitute into it. The a is m, the b is minus 1, the c is minus 5m minus 3. The x1 is 2 and the y1 is minus 4. So we substitute into our formula and we let it equal to the square root of 8 because the radius is the square root of 8. So then we simplify. M by 2 is 2m, minus 1 by minus 4 is 4, and then we just bring down the minus 5m minus 3. And then we have the square root of m squared, and minus 1 squared is 1. And don't forget your modulus symbol. So then 2m minus 5m is minus 3m, 4 minus 3 is 1, and the square root of m squared plus 1 just stays as it is. So then we square both sides, so that gets rid of the modulus symbol at the top, it gets rid of the square root at the bottom, and it gets rid of the square root at the right. So we also have to square minus 3m plus 1. So minus 3m plus 1 squared is minus 3m plus 1 multiplied by minus 3m plus 1, which gives us 9m squared minus 6m plus 1. And again, that's over m squared plus 1, and that's all equal to 8. So we multiply both sides by m squared plus 1. So that gets rid of the m squared plus 1 on the left. And then 8 times m squared plus 1 gives us 8m squared plus 8. Then we bring everything over to the left-hand side to give us m squared minus 6m minus 7 is equal to 0. Factorising gives us m plus 1 times m minus 7 is equal to 0. So m is equal to minus 1 or m is equal to 7, which are the slopes of the two tangents. So our two tangents, now we have the slopes of them, minus 1 and 7. So now we need to come up with the equations of our two tangents. So the slope is minus 1, and a point that it goes through is 5 minus 3. That's our exterior point. We label the point x1, y1. We substitute into our equation of a straight line formula, and we end up with x plus y minus 2 is equal to 0. So this is the equation of one of our tangents. We do the same thing then with the slope of 7, and the same point, 5 minus 3. That's that exterior point. Substitute into the formula, and we get 7x minus y minus 38 is equal to 0. Thus, the equations of the two tangents are x plus y minus 2 is equal to 0, and 7x minus y minus 38 is equal to 0. So that's the equations of our two tangents. Circles with axes as tangents. If a circle touches an axis, the x or y axis is a tangent to the circle, then one of the coordinates of the centre of the circle is equal to the radius. So a circle touching the x-axis. So here's our x-axis, here's our y-axis, here's our circle, and it's touching the x-axis. So the radius is equal to the modulus of minus f. So if this is our centre point, minus g minus f, then the minus f represents the y value. So this must be minus f on our y-axis. So this distance here must be minus f, but we have our modulus symbol to show that it must be positive because length is always positive. So the radius formula, the square root of g squared plus f squared minus c, is equal to the modulus of minus f. We square both sides, giving us g squared plus f squared minus c is equal to f squared. The f squareds cancel. We're left with g squared minus c is equal to 0, so g squared is equal to c. So if a circle is touching the x-axis, then g squared is equal to c. Likewise for a circle touching the y-axis. Here we have the x-axis, here we have the y-axis, here's our circle, and we can see it's touching the y-axis. Again, this is the centre point minus g minus f. So this point here, the point at which it's touching the y-axis, must be a distance of minus g, because this would be minus g on our x-axis, so this must be a distance of minus g. But we have the modulus symbol to show that it must be positive, because again, length and distance must always be positive. So the radius is the square root of g squared plus f squared minus c. That's equal to the modulus of minus g. So squaring both sides, we get g squared plus f squared minus c is equal to g squared. Cancelling out the g squared on each side, we have f squared minus c is equal to 0. And solving for f squared, we get f squared is equal to c. So for circle touching the y-axis, we have f squared is equal to c. The x-axis is a tangent to the circle K. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Show that g squared is equal to c. So our equation is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. The centre we know is minus g minus f. The minus g is our x value, the minus f is our y value. The radius is equal to the formula of the square root of g squared plus f squared minus c. From the diagram we can see that the radius is equal to the modulus of minus f. So if this is our circle and it's touching the x-axis, then this point here where it touches the x-axis, our point of tangency, we can see that this lines up with minus g on our x-axis, and it lines up with minus f on our y-axis. So this distance here, which is also the radius, must be a length of minus f. And we have our modulus symbol to show that it's positive. So the radius is equal to the modulus of minus f, and just as in the previous slide, we end up getting g squared is equal to c. Part 2. The 2 points 2, 1 and 3, 2 are also on the circle K. Find the two possible equations for K. So 2, 1 is on the circle, so we swap each x value for 2 with brackets and each y value for 1 with brackets. And then multiplying out the brackets and getting everything on the left of the equal sign, we get 4g plus 2f plus c plus 5 is equal to 0. Likewise with the point 3, 2, we swap each x value for 3 with brackets, each y value for 2 with brackets, multiplying out the brackets and getting everything on the left of the equal sign, we get 6g plus 4f plus c plus 13 is equal to 0. So now we have three equations. We have g squared is equal to c, we worked that out in part 1. We have 4g plus 2f plus c plus 5 is equal to 0, that's equation 2. And we have 6g plus 4f plus c plus 13 is equal to 0, that's equation 3. So we're going to take equation 2 and equation 3 and we're going to replace the c with g squared in both of them. So we swap that c for g squared and we swap that c for g squared. So now we have equation 4 and equation 5. So from equation 4, we express f in terms of g, and then we put this into equation 5. We're going to put this into this equation. So equation 4 is 4g plus 2f plus g squared plus 5 is equal to 0. So we're going to rearrange to get the f on its own. So we end up with 2f equals minus 4g minus g squared minus 5. So bringing these over the equal sign and changing the sign. And then dividing across by 2 to get the f on its own, we have f equals minus g squared minus 4g minus f all over 2. So we're going to take this and we're going to substitute it into equation 5. So we're going to swap that f for a set of brackets, a big set of brackets, and put this into the brackets. So we end up with minus g squared minus 4g plus 5 all over 2 in the brackets. And we just bring everything else down. So then we multiply out the brackets. So we're going to bring down the 6g. Then 4 times minus g squared is minus 4g squared divided by 2 is minus 2g squared. Then 4 by minus 4g is minus 16g divided by 2 is minus 8g. And then 4 by minus 5 is minus 20 divided by 2 is minus 10. Bring down the g squared, bring down the 13. Then we simplify and we end up with g squared plus 2g minus 3. We factorize and we solve. So g is equal to minus 3 or g is equal to 1. So remember there's two possible equations for the circle K. So let's start off if g is equal to minus 3. Well, c is equal to g squared. So we can swap that g for a set of brackets and put minus 3 into it. So minus 3 squared is 9. So c is equal to 9 when g is equal to minus 3. And f we know is equal to minus g squared minus 4g minus 5 all over 2. So we're swapping each of the g's for minus 3. and we end up with minus 1. So f is equal to minus 1, c is equal to 9, g is equal to minus 3. So we sub these into our equation of the circle, and we end up with x squared plus y squared minus 6x minus 2y plus 9 is equal to 0. So we swap the g for minus 3 with brackets, we swap the f for minus 1 with brackets, and we swap the c for 9. Now, in our second case, so remember we want two possible equations for k, so to get our second equation, this time g is equal to 1. So we know c is equal to g squared, so we swap the g for a set of brackets and put 1 into it, so we get 1. So c is equal to 1 when g is equal to 1. And f, again, we know, is equal to minus g squared minus 4g minus f all over 2. So swapping both of those g's for 1, we end up with minus 5. So minus 5 is equal to f. So again, we take our general equation of the circle. We swap g for a set of brackets, we put 1 into the brackets. We swap f for a set of brackets, we put minus 5 into the brackets. And we swap c for 1. And then we end up with x squared plus y squared plus 2x minus 10y plus 1 is equal to 0. So these are our two equations of circle K.